Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how we are mapping the skeleton of the universe. So let's get started. What does the universe look like on the largest possible scales? Galaxies are not scattered randomly through space. Instead, they are arranged in vast, interconnected structures, forming what astronomers call the cosmic web. But most of this structure is invisible. Recently, astronomers using China's Fast Radio Telescope identified a thin filament of galaxies within the Ursa Major supergroup. This structure stretches across enormous distances, with galaxies arranged in a nearly straight line. It provides direct evidence of the universe's large-scale structure, something that was previously difficult to observe directly. The challenge is that most of this structure is not directly visible. The universe is shaped by dark matter, which does not emit or reflect light. This invisible material forms a kind of gravitational scaffolding, guiding where galaxies form and how they evolve. But if we can't see dark matter, how do we map the structure it creates? Instead of observing galaxies alone, astronomers look for something more subtle: hydrogen gas spread between them. This gas emits faint radio signals that can be detected with extremely sensitive instruments like FAST. By mapping where this hydrogen is located and how it moves, astronomers can trace the underlying structure of the cosmic web. This is where measurement becomes inference. Astronomers do not see the cosmic web directly. Instead, they detect faint signals from hydrogen gas distributed along these invisible filaments. By analyzing the distribution and motion of that gas, they can reconstruct how matter is organized across vast distances. The result is a map, not of individual objects, but of the structure connecting them. This particular observation revealed a thin, coherent filament within the Ursa Major supergroup. That's the key result. It provides direct evidence that galaxies are arranged along narrow, filament-like structures. And that supports the idea that dark matter forms a cosmic framework guiding the growth of galaxies. More broadly, it shows the universe is not uniform, but organized into a vast interconnected network. We cannot see the universe's structure directly, but by tracing faint signals from hydrogen gas, we can begin to map the hidden framework that shapes everything we observe, not by observing the structure itself, but by interpreting the signals that reveal it. So that concludes our discussion on mapping the skeleton of the universe. We'll be back again next week for another new discovery in astronomy. So until then, have a great day, everyone, and I will see you in class.